Hey everyone, so the question is valid anagram. It's an easy level question and you'll be given two strings and you have to return true if T is an anagram of S. Otherwise you have to return false. So let's say S is cat and T is TAC. So an anagram is basically a string, and if we say that ST is an anagram of S, that means that if we rearrange the letters in this string, it will form this. So we can say that T is actually an anagram of S because TAC can be rearranged to CAT and it will be equal to the string S. So T is actually an anagram of S. So the first approach that we can use is simply just sort both of them. And here we have converted it first to list, which is actually not required because when you pass something in the sorted function, it returns it as a sorted list on its own. So we didn't have to convert the string into list. We could have just skipped this part. So if you will sort S using the sorted function, this will become A, C, and D. It will sort it according to the alphabetic order, and same T will also become A, C, and T. Since these both are equal, we know that T is an anagram of S, so we will return true. Else if it was not equal, we would have returned false. Since Python's sorting algorithm takes order of n log n time, so that will be its time complexity. And since we are not using any extra space here, so space complexity will be order of 1, that is constant. And this will work just fine. You can just do this and it will pass all the test cases. Now there can be another solution which will take order of n time. In this, first of all, before even moving forward, we will check if the length of both the strings are same or not. Because if let's say S was cat and T was tax, this is length 3, this is length 4. So no matter how we arrange T, it will never form S. Even if we rearrange like this, there will be n extra S here, which no matter where we place it, here or here, it will never be equal to S. So before we will proceed, we have to make sure that the length of both the strings are equal, else it won't work. So after checking the length, if they are equal, we will move forward. We will make two dictionaries. C1 will keep track of S and C2 will keep track of T. So we are traversing to S, so this will take order of n. And if for I in S, basically we'll just get one letter one by one. So if I is not in C, first of all C is empty, so we will just in C1 we will just add C and assign it the value 1 because it's not there. So this is the first time we are encountering it. If it was already there, then we would have just increased the count by 1. So C is encountered first time, A is also encountered first time, T is also counted first time. Then we will do the same with T. This will also take order of n. So T is encountered first time, so we will make it 1. A for the first time 1, and C for the first time 1. So after doing this, we will traverse to C1. For I in C1, this will give us the keys of C1. This will also take order of n time because we are traversing through it only once. So first of all, we will check if I is not in C2, this one. That means anagram T will never be an anagram of S, because no matter how we arrange it, if it's missing the letters which was in C, S, then no matter how we arrange T, it will never form S. So we will directly return false. Else, if they exist, if a letter in S exists in T, but the count is not the same, then also it will never form T will never form be an anagram of S, because if S is cat and T is CAC, so the C is 2 times. So no matter how we arrange CAC, it will never form CAT cat. So then also we will return false. So this for loop we will check C. C is here and C here. Count is also same. So we will move on. We will check A. A is here. Count is also same. We will move on. T is here. T is here. Count is also same. We will move on. Since the for loop is complete without returning false even once, so we know that T can be rearranged to form S. So in the end, we will return true. This approach take order of n time, since we are already traversing through all of them once. But since we are using dictionary to store the count of all the letters appearing in S and T, so the space complexity will become order of n, which is more than the last approach, which was constant. But we have to compromise on that because time complexity is being reduced from nlogn to order of n. So thanks for watching.